picture of all the points to satisfy. Let's take equation number 2. If I make a picture of all the points to satisfy all the x, y, z points, let's solve this equation. Well, first of all, the origin is not one of them. X, y, z being 0, 0, 0 would not solve that equation. What are some points that do solve the equation? Let's see, maybe if x is 1, y and z could be 0. That would work, right? So there's one point. I'm looking at this second equation here. Start this. Let's see. Also, I guess if z could be 1, x and y could be 0, so that would just go straight up that axis. And probably I want a third point here. Let me take x to be 0. Say x to be 0, z to be 0, then y would be minus half, right? So there's a third point. Let's see. I want to put in all the points to satisfy that equation. Do you know what that bunch of points will be? It's a plane. We have a linear equation, then fortunately the graph of the thing, the plot of all the points that solve it, are a plane. So I can treat these 3 points to determine a plane, but your lecture is not Rembrandt, and the art is going to be the weak point. So I'm just going to draw a plane, right? It's a plane somewhere. That's my plane. That plane is all the points that solve this guy. Then, what about this one? 2x minus y plus 0z. So z actually can be anything. Again, it's going to be another plane. Each row in a 3 by 3 problem gives us a plane in 3 dimensions. So this one is going to be some other plane. Maybe I'll try to draw it like this. And those 2 planes meet in a line. So if I have 2 equations, just the first 2 equations in 3 dimensions, those give me a line. The line where those 2 planes meet. And now the third guy is a third plane, and it goes somewhere. Okay, those 3 things meet in a point. Now I don't know where that point is, but linear algebra will find it. The main point is that the 3 planes, because they're not parallel, they're not special, they do meet in one point, and that's the solution. But maybe you can see that this row picture is getting a little hard to see. The row picture was a cinch when we looked at two lines meeting. When we look at 3 planes meeting, it's not so clear, and in 4 dimensions, probably a little less clear. So, can I quit on the row picture? I'll quit on the row picture before I've successfully found the point where the 3 planes meet. All I really want to see is that the row picture consists of 3 planes, and if everything works right, 3 planes meet in one point, and that's the solution. Now, you can tell I just wrote the column picture. Okay, so let me take the column picture. That's x times, so there were 2 x's in the first equation, minus 1 x, I'm just taking no x's in the third. It's just the first column of that. And how many y's are there? There's minus 1 in the first equation, 2 in the second, and maybe minus 3 in the third. Just the second column of it. And z times no z, minus 1z, and 4. And it's those 3 columns, right, that I have to combine to produce the right-hand side, which is 0, minus 1, 4. we want to know what combination of those three vectors produces that. Shall I try to draw the column picture then? So since these vectors have three components, so it's some multiple. Let me draw in the first column as a 4, like x is 2 and y is minus 1. Maybe there's the first column. Y, the second column has maybe a minus 1, a 2, and y is a minus 3, somewhere there possibly, column 2. And the third column has no 0, minus 1, 4. So how do I draw that? Nothing in this is the first component, the second component is a minus 1, maybe up here. That's column 3, that's the column 0, minus 1, and 4. This guy. So, again, what's my problem? What this equation is asking me to do is to combine these three vectors. The right combination to produce this. Well, because it is special problem. That right-hand side that I'm trying to get is actually one of these columns. So I know how to get that. So what's the solution? What combination will work? I just want one of these and none of these. So x should be 0, y should be 0, and z should be 1. That's the combination. None of that, one of those is obviously this column 3 is actually the same as B. I made it work that way just so we would get an answer, 0, 0, 1. So somehow that's the point where those three planes met, and I couldn't see it. Of course, I won't always be able to see it on the column picture either. It's the next lecture, which is about elimination, which is the systematic way that everybody, every bit of software too, production, large-scale software would solve the equation. So the lecture that's coming up, if I add that to the syllabus, will be about how to find x, y, z in all cases. And I just think again, though, about the big picture. By the big picture, I mean, let's keep this same matrix on the left, but imagine that we have a different right-hand side. Oh, let me take a different right-hand side. So I'll change that right-hand side to something that actually is also pretty special. Let me change it to, suppose if I add those first two columns, that would give me a 1 and a 1 and a minus 3. There's a very special right-hand side. I just cooked it up by adding this one to this one. Now, what's the solution with this new right-hand side? The solution with this new right-hand side is clear. Now I took one of these, and none of those. So actually it just changed around to this when I took this new right-hand side. So in the row picture, I have three different planes. Three new planes meeting now at this point. In the column picture, I have the same three columns, but now I'm combining them to produce this guy. And it turned out that column 1 plus column 2, which would be somewhere there is the right column. One of this and one of this would give me the new B. Okay, so that's like we squeezed in an extra example. But now think about all B's, all right-hand sides. Can I solve these equations for every Can I say that question? So that's the algebra. and I solve AX equal B for every B. Let me write that down. And I solve AX equal B for every right-hand side. I mean, is there a solution? And then, if there is, elimination will give me a way to find it. I really want to ask, is there a solution for every right-hand side? So now, can I put that in different words? In this linear combination of words? So in linear combination of words, do the linear combination of the column